over 2 as it approaches 1 is equal to -1.
Using the definition.
Precise definition.
Good. For every epsilon positive, there exists a delta positive such that every time I pick x close to 1, then I will have from here 1 minus 3x over 2 plus 1 less than epsilon. So for every epsilon positive, I will find the corresponding delta positive such that every time I pick x close to 1, not 1, but close to 1, then the function value will be close to -1, minus 1. So there are 2 steps. Step number 1 is find delta. This is the step, and I have to write that. Number 1, find delta. And then 1 minus 3x plus 2 divided by 2, I have to find the least common denominator. And you know what we're after. We're after this. Yes? So then we have -3x plus 3 over 2 in absolute value less than epsilon. Remember, factor simplify, descending order, no negative leading coefficient. Factor simplify, descending order, no negative leading coefficient. You should always have that in the back of your mind. At this point, I have to factor, but I can't factor out of the absolute value. That will not be allowed. So I have to write -3 in parentheses x minus 1 divided by 2 less than epsilon. That has to be my next step. And now I can use the property that says the absolute value of -3, the absolute value of a negative x minus 1, the absolute value of 2 less than epsilon. So if from there you already have the answer, I can't give full credit. You have to show the properties you're using. We cannot factor out from an absolute value. So then now this becomes 3, the absolute value of x minus 1, 2 less than epsilon. Now it's fine if you multiply both sides by 2/3. So you have 2 epsilon over 3. And you will say, here it is. This must be it. Why? Because I'm comparing this to this. I have x minus 1 on both sides, on the left-hand side, and this must be delta by comparison. So you have to write step 2, show that delta equals 2 epsilon over 3 works. I will not ask you to reverse the steps, but just say by reversing the above steps. Yes, Ricky? Yes. So you must show those steps, please. Any questions on any of this? Any questions? Any questions? Any questions? Okay. Any questions? Any questions? Do I need to go back to any of these pages? Do I need to go back? Let me know. Yes, please, Vanessa.
I don't know if you went over 5 letter A. There's limit arctan. I'm sorry, limit x approaches 0 from the right arctan.
Part A?
Yeah.
So arctangent, you have to remember the graph. The graph of arctangent is this. Between -π/2 and π/2.
Yeah,
So when 1 over x, when x approaches 0, from the right, 1 over x approaches infinity, so then arctangent of infinity is π/2.
okay. I had it down, I just didn't know like why.
Yes. It's all based on the graphs that I keep coming back and graphing and graphing. Yes, that's why I'm doing that. To refresh your memory on those two, on those graphs. Any questions? Okay, for the rest of the time, this part is not going to be on the test on Thursday, of course. And I strongly recommend if you still have questions, please come to class early on Thursday so we can go over any of the questions that you may have after you study. You may still have questions, and I'll be more than happy to help you. Okay, so in chapter 3, we're going to talk about differentiation rules. That's the title of the chapter. Differentiation rules. And in the first section, we are going to deal with polynomials and exponential functions. Whatever we cover today, I don't know, but the title number 1 is just the first section. Yes. So the entire chapter is another big chapter. It has 10 sections. It's huge. It's a huge chapter, 10 sections. So today we're starting it with the preliminaries, just the simplest possible differentiation rules, and they will involve polynomial and exponential functions. So we do know, which is not a polynomial function, we do know this by now. We proved it, we analyzed it. What was the derivative of the square root of x? Very good. Although this part is not in polynomials, but it can be changed into one, sort of. Okay, so this is what we know so far. Let's take a look at f of x. Let's say x squared. What function is this? Quadratic, very good. Is it the simplest possible quadratic function that you can think of? Yes, it's the absolute simplest quadratic function. Let's find its derivative. Correct. Did we do this? Okay, excellent. So I don't have to do it again. Oh, awesome. So that f prime of x in this case is 2x. We did prove it. We don't have to prove it. Okay. So then let's say we are looking at a function now that is x to the nth power. It's not impossible, but it will take some time to use the derivative function definition to determine the derivative of this. The limit as h approaches 0 from f of x plus h minus f of x over h. It will take some time. What do you think this will equal to? N x to n minus 1. This is what we call the power rule. This is what we call the power rule. So then here's another example for you. Can anyone help with x to the 7th?
7x to the 6th.
Very good. Here's another very important rule. If we have a constant times a function, and we want to differentiate this, yes, but the constant stays outside because we are only differentiating the function. So here's an example. If we have 5x to the 3rd and we want to differentiate this, we bring 3 down, but we have to multiply it by 5 because 5 is multiplied by x cubed. So 5 stays outside, but when I differentiate this, I will get 5 times 3 times x squared, therefore 15x squared. Any questions so far? Any questions? Before I let you choose problems from your book, or any problem you want, do you remember this limit law? Assuming that the limit of f and the limit of g exist, and they are whatever number. Okay, what will this equal to? Assuming the conditions are fulfilled. Very good. What do you think this will equal to, knowing that the derivative is also what? A limit. It's a limit, right? So what will this equal to then? What if I have a difference? Good. So we know how to differentiate sum of functions and difference of functions. Okay. Before we look at problems, I have one more item to discuss. Let's suppose we have this function. Can anyone tell us what function this is? Other than Love and Emily and Ricky, and I want to hear from anyone else. Very good, excellent. This is an exponential function. For this function, I would like us to determine f prime using the definition of the derivative. There is only one definition of the derivative, f prime of x. There are two definitions of the derivative evaluated at the point. F prime of a, two definitions. F prime of x, one definition. Can anyone get us started? Thank you. Very good, Braden. Thank you. H approaches 0. There is only one definition from plus h. Excellent. Awesome. This is what we've known for 5 weeks already. Perfect. So now, I copied the function. I copied h. Can anyone give us f of x plus h for this function? Very good. Awesome. Now, I would like to discuss e to the x plus h for a moment. If we have a to n times a to m, I copy the base. What do I do with the exponents? Excellent. But now I want to go backwards. So let's do this together. E to x plus h. What will that equal to? Careful. E to the x
times e to the x.
E to the x times e to the h. Do we all agree with this? I'm going to go back and replace it. And I forgot, of course. Well, we already know this, but I should have not omitted it. Please plug in h and tell me what you get. What do we get? Do you all agree with 0 over 0? E to the x minus e to the x, and the denominator is 0. Good, perfect. So then I will copy limit h approaches 0, e to the x times e to the h minus e to the x divided by h. Looking at this expression, you will say, I know exactly what you are going to do. And I think I'm going to do it. Exactly. What will I factor out? Very good. What is left in parentheses? That's it. Very good. Awesome. Ready? We, at this point, we're not equipped to perform or find this limit algebraically or using calculus. But we have another way. So let's do it with another way to see what that is. So here it is. Let's plug in the function. We're interested in e to the x minus 1 over x. I don't have h in the calculator, so I can't put h. So parentheses around the top, e to power x. I didn't mean that. Let me start from scratch. I always forget that it's giving me this already. Okay, left parenthesis, e to the x minus 1, close the parenthesis, and divide by x. One more time, what am I doing? Let's go back for a moment. 1 second, what am I doing? One more second, I'll go back. Okay, so I want to determine this. Forget about e to the x for a moment. So I want e to the x minus 1 over x. This is what I'm analyzing at this point. Ready? So e to the x minus 1 over x. I want to find a limit as x, you know, it's h, as h approaches 0 from either side, correct? From either side. Good. So please tell me what to plug in with second and table. What would you like me to plug in? You can I plug in 0?
Yeah.
Okay. Can I plug in 0?
No.
Absolutely not. Good. So let's say 0.2. Let's say 0.1. What am I doing? I'm getting closer from the right. Okay. Oops, I didn't mean that. 0.01. 0.00001. 0.00000001. 1. From the other side, negative 0.1, negative 0.01, negative 0.00000001. Conclusion, please. The limit is 1. So if, when age approaches 0, this piece approaches 1, can anyone tell us what is the derivative of e to the x? It's the only function that performs this way. The derivative of e to the x is itself. It's the same function. So please remember, e to the x prime is e to the x, and we proved it. We proved it with a graphing calculator. Very soon we'll be able to prove it with a formula, with a theorem. Sorry. Okay, so now we're ready. Any problem you would like to practice with? Let's start on page 181. Page 181. First, let's choose between 1 and 32. If you don't have your book, it's okay. I will choose. Okay, let's start with 14. Please choose the next one when you're ready. So y or f of x, same thing, x to 5/3 minus x to 2/3. Now, if the problem is given using y, I should use dy over dx. If the problem is given as f of x, then I should use f prime of x. That's a general rule. Not necessarily, doesn't matter. I wrote both for you. So let's say dy over dx, which is the same thing with f prime of x. Identical. So f prime of x or dy over dx, till you get used to it, I may write both. I bring down the power and multiply by x, subtracting 1 from the power. 5/3 minus 3/3, it's 2/3. Minus, I bring down 2/3, and I subtract 1 from 2/3, and I have negative 1/3. For this particular problem, you're not asked to further simplify this. In other situations later, we would have to. Yes?
How did you get that? Please.
So 5/3 comes in front, and I subtract 1 unit from 5/3, and I get 2/3. And then 2/3 comes in front, and I subtract 1 unit from 2/3, and I get negative 1/3. Better? Yes. Do you want to go ahead? I'm sorry? Yes, I'm using this formula. So the power comes in front, and I subtract 1 from the power. 5/3 minus 1 is 2/3. And that's why I wrote 2/3. And from 2/3, when I subtract 1, I get negative 1/3. Better, everyone? Yes? Okay. Let's choose something else. Like, for example, 22. And that's it. That's the derivative of this function. Yeah. So 22. We have y equals the square root of x plus x divided by x squared. I don't like this function. But it has only one term in the denominator. So I can separate it into 2 fractions. Why 2? Because I have 2 terms at the top. If I had 3 terms at the top, I would have separated into 3 fractions. But right now, I will separate into the square root of x over x squared plus x over x squared. What power is the square root of x? The square root of x is x to? Very good. So then I have x to 1/2 minus 2 plus, I'll simplify an x, and plus 1 over x. I think we determined the derivative of this, 1 over x. Did we? That's okay. If we didn't do it, then let's replace this by x to negative 1. I'm going to erase it. I thought I did this, but maybe not. Okay, everyone with me, please? Yes? So I simplify the x with an x, and 1 over x gets changed into x to negative 1. So this is very important. All this preliminary work makes our life so much easier. And now we can differentiate and get dy over dx using the power rule, right? So let me write one more time. 1/2 minus 2 is negative 3/2. X to negative 3/2 plus x to negative 1. This is the function that I would like to differentiate. 1/2 minus 4 over 2 is negative 3 over 2 plus x to negative 1. So now this reduces to the previous case. I have two terms. I'm using the power rule on both. I will bring negative 3/2 in front and subtract 1 from the power. I will bring negative 1 in front and subtract 1 from the power. So negative 3/2 x to negative 3 over 2 minus 2 over 2, right? Negative 5/2 minus x to negative 2. And you don't need to do anything else to this problem. You can say, are they all going to be that weird? No.
Can you just go over it again?
From here.
Yeah, just go. Yeah.
So negative 3 in front, negative 3 over 2 minus 1 integer is negative 5/2. And then I bring down negative 1 and subtract 1 from the power. Better? Better? Everyone? Yes? Okay. So since you asked about that, Jared asked about that problem with the equation of the tangent line, let's choose one. So we have find the equation of the tangent line to the curve, 33, 34, find the equations of tangent lines and normal line to the curve. So I prefer choosing a problem in which we determine the tangent line and the normal line. So let's look at 36, because 36 does more than just finding the equation of the tangent. Ready? Yes? Okay, 36. And this is on page 182. We are given y, which is x to the 4th plus 2. Yes, of course, I copied from something else. So y equals x squared minus x to the 4th. And we are given the point 1 comma 0. Sorry about that. So for this function, we are asked to find two things. The equation of the tangent line at the point 1 comma 0 and the equation of the normal line to the same function at that point. Let me explain what that means. So let's suppose this is the function and this is the point 1 comma 0. At 1 comma 0, we will have a tangent. This is the tangent. And we will have to determine that equation. And we will also have a normal line, which is perpendicular at that point, perpendicular, 90 degrees everywhere. This is the normal line. So at this point on the graph of the function, we're asked to find equations of two lines. One that is the tangent and the other one that is perpendicular to it at that point, called the normal line. Okay, so I know that how to determine the equation of any line will be y minus y1 equals the slope times x minus x1. In both cases, if it's tangent or normal, it doesn't matter. I have 1 comma 0. But all I have to determine is the slope of the tangent, and after that, the slope of the normal line. Let's suppose the slope of the tangent is 5. What will be the slope of the normal line? Negative 1/5. Right? The product, I'm going to write that. The product has to be negative 1. What if I get this one to be 1/3? What will be the slope of the normal line? Very good. But now how do I determine the slope for the tangent? What do I have to do? Find the derivative. dy over dx. Can anyone give us a derivative of this function?
2x minus 4x to the third.
How will I determine this number? By, and this is how we like to write it, replacing x by 1. So what is this notation all about? It says the derivative of this function evaluated, determined, in other words, when x is 1. So what do we get? One more time. So what is it? Very good. So then the slope of the tangent line is -2. So the equation of the line will be y equals -2 x minus 1. y1 is 0. Slope is -2 x minus 1. I distribute. So y equals -2 x plus 2 is the tangent line at 1, 0. Yes, please.
How did you get that last, or like the second to last equation, the y equals, yeah, how did you get that?
Y minus 0 equals -2 x minus 1.
X is that from the x equals 4, right, right?
This is the derivative. Evaluate at 1 because that's the point we're given. Okay. Everything else? Everything else okay? Okay, so now I have to find a normal line. I still have y minus y1 equals the slope times x minus x1. I still have 1 and 0. But since the slope of the tangent line at that point was -2, what will be the slope of the normal line this time? Excellent. Thank you. So then y equals 1/2 x minus 1. And I distribute, and I'm done. Y equals 1/2 x minus 1/2. And this is the normal line. Any questions on this? Any questions on this?
So basically,
Yes?
when we do the 1/2, we're just reversing the answer from the first equation.
So let's review that. Two lines are perpendicular if m1 times m2 equals -1. This is the way I like to remember it. But I know you were taught this, but it's the same thing. If you cross multiply, you get my idea. Why do I prefer to remember it like this? Because it's so much easier to say. The product is -1 instead of saying the slope of the line that is perpendicular to the other is the negative reciprocal of the first slope. Product -1. Same thing. If you put this over 1 and cross multiply, you get that. It's up to you. Is that better? Hold on just 1 second. Is that what we meant? Okay, yes, Jerry?
Can you just go back up?
Yes? Any questions here? Please, yes, you?
So what is M1?
If M1 is 5, this is -1/5. If M1 is 1/7, this is -7. So that the product is -1.
What if it's like, what if M1 is
2/3. 2/3. -3/2. Yeah, the product to be -1.
then the bottom would be 1 minus -1/3.
Yeah, but then you have to flip it. It's much easier to say 2/3, -3/2. But if you put here 2/3, -3/2. No matter what you do, you get the same answer. Very good. Any questions?
Can you go back up?
Yes. Anything else? Anything else? We will come back to other problems. I would like to move forward with the product and the quotient rules. We will come back in 3.1 with 2 other problems. So 3.2, the product and quotient rules. You would have a chance, you can use this on the test on Thursday to check only. You may want to use a quotient rule to verify, and we can verify any of the quizzes that we had the difference quotient for with the product or the quotient rule. Okay, ready? So if we have a function multiplied by another function, let me give you an example. Let's say x squared plus 3 multiplied by e to the x. This is a function, and this is another function. So this is a situation in which I'm given the product of two functions, and I want to differentiate that. And there is no point in multiplying, distributing here. I can use the product rule. What does the product rule say? This is nothing what you would expect. You would not expect this. F prime g plus f g prime. Do not ever try to differentiate the product in any other way. It's not going to work. What I would like to tell my students, I always tell my students, if they prefer this, always keep in mind first function times the second function prime. It's the first function prime times the second plus the first times the second prime. Your book twists this a little bit, or you can say I'm twisting it a little bit. I just like to have 1, 2, 1, 2. Your book says 1 prime 2 plus 2 prime times 1. If you want to use that, that's fine too. It's the same thing. If I put 2 prime times 1, it's the same thing. Okay, so let's differentiate this. I have to differentiate the first function. What do I get? What is the derivative of 3? I should have mentioned that in the previous section. Is a constant prime, does not change. There is no rate of change for that. So any constant prime is 0. Perfect. So this is this piece. But now I have to multiply by the second function. Plus, now I copy the first function, and I multiply by the second one prime. But what is the derivative? This is the nicest function ever. What is the derivative of e to the x? E to the x. You can leave it as is, or you can factor out what is the common factor of this term and this term. Good. And then I'll put everything in order. X squared plus 2x plus 3. And this is good enough. And this is the product rule. Yes, please. Sure. So this is the first function. This is the second function. I differentiate the first function, and I get 2x. Times the second function. So I copy. And then plus. I copy the first function, and I differentiate the second one. But when I differentiate the second one, I get e to the x. And then I factor out e to the x, and I put these three terms in order. X squared plus 2x plus 3. Yes? When we differentiate x squared, we bring down the power, and we subtract 1 from the power. And times the second function. And 3 prime is 0. What is the rate of change of 5? You have $5 in your pocket. How fast can that change? There's no rate of change of a constant. It's 0. Imagine a constant. If I graph it, y equals 5. What is the rate of change? What is the slope of this line? That's why the derivative of a constant is always 0. Yes, Ricky?
I can get
Yes?
2x.
When I differentiate this function, I only get 2x. So I have f prime, which is 2x. Then I copy the second function. And then plus. I copy the first function now. And I multiply by the second function prime. And then I factor out e to the x. Yes. Is that okay, Ricky?
Yeah.
Vanessa?
I explained, I understand the rest of it, I just don't, can you work out how we differentiated 2x plus 3? Because I don't understand.
Right. When we differentiate the sum of two functions, I differentiate the first function, plus I differentiate the second function. When I differentiate x squared, I get 2x. When I differentiate 3, I get 3. From the previous section. Very good. Other questions here? Okay, let's look at the quotient rule. because I wanted to show you how to check your answers. Ready? The quotient rule is a function divided by another function. Again, we have to remember this. We're going to remember it once we apply it several times. The numerator kind of looks like the product, but it's minus in between. Same thing with the product, but minus. The denominator now is not differentiated, it's just g squared. So from any of the previous quizzes, can you give me a rational function so we can check our answer that we determined with f prime? We found f prime using the definition. But now I would like to find f prime using this, the formula, the differentiating ratio. So can anyone give us a function that we had on a previous quiz? I've returned some quizzes today. I'm sure you'll find a ratio there, so we can check. 1 minus x over?
2 minus x over x plus 1.
2 minus x over x plus 1. Very good. Prime. Now remember, this is the first function. This is the second function. So again, if you'd like to remember it like this, the first function times the second minus the first times the second prime over the second squared. One option would be to not to forget, just write x plus 1 squared already in the denominator. So now we have to differentiate the numerator. Can anyone give us the derivative of the numerator? -1. Very good. Awesome. So this is -1. I have to multiply it by the denominator. I have to copy minus. I have to copy the top. And now I have to differentiate the denominator. Can anyone give us the derivative of the slope of this line? In other words, 1. Now, you understand that if you would make this mistake and simplify x plus 1 with an x plus 1 from the denominator, there would be a tragedy, correct? Okay, perfect. So what I would like to do, I would like to put a minus sign in front. Factor out -1 from both terms. And then I have x plus 1 plus 2 minus x divided by x plus 1 squared. These two go away, and the answer is -3 over x plus 1 squared. What did we get when we applied the definition? What was the answer before? Of course. But this takes what? One line. The other one took like 4. So you can always, if you remember the formula for Thursday, you don't have to, but you can always check. Any questions? Yes, please.
Okay, so the f is 2 minus x.
Yes. So I differentiate the top and I get -1, and I copy the bottom. Minus.
Okay, I don't want to know how. Can you just want to find out what?
X prime is 1. 1 prime is 0. The derivative of x is 1. Bring down 1, subtract 1 from the power. And you get 1 times x to 0. So x prime, to the first power prime is 1 times x to 1 minus 1, which is 1, because x to 0 is 1, so that's how you get 1. Very good. Is that okay?
Yeah.
Yes, Chris?
If on the test we were told to find the derivative of a product.
You're using the definition. But you can check on the side and see if you got the correct answer using this formula.
So we'd have to use the definition.
Yes. Yes. Not moving forward. From test 2 on, you can do whatever you want. But just on test 1. Other questions here? Everything okay? I have 1 more minute if you'd like to do anything else, or we can just talk about your test. If you have any questions for me. Yes?